Yeah, welcome back, my dear friends. Today, we will continue from differentiation of inverse trigonometric functions. Hope you have understood last video class what we learned about implicit functions and their differentiation. Now we are going to do the differentiation of inverse trigonometric functions. Remember, inverse trigonometric functions are also continuous functions. So there is no problem. We can go ahead with the differentiation of these functions. Let us start. Let us go to the whiteboard and start with the sine inverse x. So the first sum, here we'll write down the heading. Today's heading is differentiation of inverse trigonometric functions. Inverse trigonometric functions. So first one we'll start with sine inverse x. So the first one, differentiate sine inverse x. It's a very simple sum. In fact, let y is equal to sine inverse x. Take both sides. Take both sides sine. So we are multiplying both sides by sine. So what you will get here, sine y is equal to sine of sine inverse x. So sine y is equal to sine and sine inverse. When you multiply, they get cancelled and you are left with only x. Now let us differentiate. After converting this into simple form, differentiate both sides with respect to x. With respect to x, then what will happen? Sine y will become cos y, and y differentiation is dy by dx. X differentiation with respect to x, that is dx by dx, which is nothing but 1. So therefore, dy by dx is equal to 1 by cos y. Actually, sum ended here. Still, we have to write simplification. 1 by root of 1 minus sine square y. Cos y is nothing but root of 1 minus sine square y. 1 by root of 1 minus, what is sine y? Sine y is called as x. So sine square y will become x square. So this is the differentiation of sine inverse x. Let us do the second one. Differentiate cos inverse x. Differentiate cos inverse x. Same procedure, y is equal to, let y is equal to cos inverse x. I remember having told you that in place of y you can also write f of x. So there is no difference. Either y or f of x doesn't matter. So better we use right now y. Let y is equal to cos inverse x. So again what we should do, multiply both sides. Multiply both sides by cos. So we are multiplying by cos because it is cos inverse here. Cos y is equal to cos into cos inverse x. Cos and cos inverse will get cancelled and get x here and then here cos y. Now we will differentiate both sides with respect to x. Differentiate both sides with respect to x. Then what will happen here? Cos differentiation minus sine y, y differentiation dy by dx, x differentiation is 1. So therefore, dy by dx is equal to 1 by minus sine y, or minus 1 by sine y, or minus 1 by root of 1 minus cos square y, or simply minus 1 by root of 1 minus x square. Because cos y is called x here. So cos square y becomes 1 minus x square here after substitution. So this is cos inverse x differentiation. Another third one we are having tan inverse. Differentiate tan inverse x. So same procedure, let y is equal to tan inverse x. Take both sides tan. Take both sides tan. Then what will happen here? Tan y is equal to tan of tan inverse. Tan of tan inverse means they get cancelled and you are left with x this side, here tan y. So differentiating both sides with respect to x. You have to write all the time with respect to x, remember this. Tan y differentiation is secant square y differentiation is dy by dx, x differentiation is 1. So dy by dx is equal to 1 by secant square y. 1 by secant square y is nothing but, from the trigonometric identity, secant square y is nothing but 1 plus tan square y. So this is nothing but, again, for tan y you can substitute x, tan square y becomes x square y. Sorry, x square. So differentiation of tan inverse x also we have completed. Sin inverse x, cos inverse x, tan inverse x, all three are very, very important. So please remember, keep doing. So based on this inverse trigonometric, let us do a few sums and then conclude this video. Let us do first sum. Differentiate y is equal to sin inverse 2x divided by 1 plus x square. These sums I have taken from NCERT textbook. I remember exercise 5.3, I think. Please check up. So this sum, how to do? Here, we cannot directly apply the formula. If you apply, it will become more cumbersome. So we will put one substitution here. What is our formula? Our formula is differentiation of sin inverse x. We have done this 1 by root of 1 minus x square. Straight away we can use this. But in the place of x here, you are having a very big function. 2x by 1 plus x square. So it becomes complicated. We cannot put directly and then say if sum is over. Like, we are supposed to put substitutions. Let us put x is equal to tan theta. Then y is equal to sin inverse 2 tan theta. Wherever x is there, you have to write now tan theta. 2 tan theta divided by 1 plus tan square theta. This one, 2 tan theta divided by 1 plus tan square theta, if you go and check in the trigonometric equations, it is called sine 2 theta. This is called as sine 2 theta. So this formula, please check up from your basic trigonometry. Sine 2 theta is also called as 2 tan theta by 1 plus tan square theta. So I am putting this here. Same thing now if you apply. Now sine inverse sine 2 theta, that is nothing but sine inverse and sine. They get cancelled. You will get 2 theta. So what is theta now here? X is equal to tan theta. Therefore, theta is called as tan inverse x. So here x is equal to, we know it is tan theta. Or I can also write tan theta is equal to x. So therefore, theta is equal to tan inverse of x. So that you write here 2 tan inverse x. That is called y here. Now y is equal to 2 tan inverse x. Let us differentiate now both sides with respect to x. Differentiate both sides with respect to x. Then we are left with dy by dx is equal to 2 divided by 1 plus x square. How it came? Tan inverse x differentiation, we know it is nothing but 1 by 1 plus x square. Previously we have done just a few minutes back. So we have to call back those formulae and then substitute here. No need to again do it. Directly we connect dy by dx is equal to 2 by 1 plus x square. Understood? No? So here we have taken substitution. Then we are going to continue to do the sum. Next, one more sum, let us see. Tan inverse differentiate tan inverse 3x minus x cube divided by 1 minus 3x square. Here also we have to take substitution. Put x is equal to tan theta. So here itself I am writing theta will become tan inverse x. Remember this. It will be useful in the another subsequent step somewhere. So if you substitute wherever x is there as tan theta, our sum will become y is equal to tan inverse 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. This is again basic trigonometric formula. Tan 3 theta, this entire thing in the bracket can put. So this will become, this entire thing is called tan 3 theta. So tan inverse and tan will cancel with each other and you are left with 3 theta. So this is also called as now theta is called tan inverse x. 3 tan inverse x. So now y is equal to 3 tan inverse x. So now differentiate both sides. Differentiate both sides with respect to x. So dy by dx is equal to 3 by 1 plus x square. So this is simple sum, but substitutions we should remember. These identities also we should remember. So one more last sum for today, that is differentiate cos inverse 1 minus x square divided by 1 plus x square. Here also same substitution. Substitution doesn't change. Put x is equal to tan theta. Then y is equal to cos inverse 1 minus tan square theta divided by 1 plus tan square theta. This becomes cos inverse cos 2 theta. 1 minus tan square theta divided by 1 plus tan square theta is called as cos 2 theta. So again cos inverse and cos get cancelled. You will be left with 2 theta. Again 2 into tan inverse x. So finally this is reduced to 2 tan inverse x. Differentiating both sides. Differentiating both sides with respect to x. dy by dx is equal to 2 divided by 1 plus x square. Okay. So last sum, differentiate sine inverse 2x root of 1 minus x square. So here, now we don't put here tan theta. In this sum specifically, we'll put sine theta. Anyway, let y is equal to sine inverse 2x root 1 minus x square. Put x is equal to sine theta. What will happen now? Sine inverse 2 sine theta root of 1 minus sine square theta. So what you will get here now? Sine inverse 2 sine theta root of cos square theta. This will become sine inverse 2 sine theta root of cos square theta is called cos theta. So this will become sine inverse sine 2 theta. 2 sine theta cos theta is called sine theta. So trigonometry you should remember like anything. This is all called y. So y is equal to therefore 2 theta. Because sine inverse and sine get cancelled. 2 into theta is sine inverse x. So differentiating both sides with respect to x, then dy by dx is equal to 2 divided by 1 minus x square under root. So d by dx of sine inverse x, 1 by root 1 minus x square. Remember, no? So that only we got. So this is how you can apply this inverse trigonometric functions formula. Substitutions are to be remembered and all trigonometric identities should be on hand. Then only you can do these sums very easily. So friends, I hope you understood this. Next class, I'll be taking on parametric differentiation and then a few sums based on that. Okay. Thank you very much. Please keep doing the sums and any doubts, leave in the comments columns.